I think is the option you should take, is that you start your class 11th 2-year integrated program with the first batch that we are starting, first set of batches, which will be next week. So in that we will be starting the full-fledged 2-year program. Of course, right now we will be having online classes, but along with online classes, we will also be having the online doubt sessions, which will be in small groups, like groups of 4 or 5, like the group we are having right now. So in those doubt sessions, you will have, the full method of interacting two-way with your faculties. So there won't be any problem because of the fact that we are not able to meet face to face. But with small groups over online platform, we can discuss and understand each other's communication 100%. Apart from that, there will be a regular lecture schedule, which will be in the full batch of 30-35, not more than that. And then, of course, we will have regular test, which will be through the online platform, similar to the ASAT test you had given, feedback of the test and everything. So in a sense that apart from the fact that we can't have physical classes immediately, we will start the full program. Okay. Whereas if you feel you need a bit of a break because of whatever fatigue and exhaustion you have undergone in the last 1 year, we all understand that also. So you can also opt for the second set of batches, which will start in the next half, like maybe 15 to 20 days from now. We will tell you the exact dates tomorrow, so you can do that also. And in tomorrow's session, we'll also talk about, what our recommendation is, whether you should take the board exam option or opt out of the board exam. Personally, I feel that, if you're already focused on your JEE 2023, so your 10th board marks don't have any further bearing, and you have put in your best effort for the prelims and all that. So you can let the 10th board go. It does not matter. You have done your best for the prelims. Based on that, you will get a good assessment internally, and don't worry about the assessment being a little bit higher or a little bit lower than your expectation. Uska koi farak nahi padne wala hai. Your class 11th admission is guaranteed in the integrated program by us. That process will be smooth. So really your 10th marks does not have any bearing. What will be important for you will be your 10th certificate in future, because that will be an age proof document for you. Very frankly, like throughout my career, that is the only use that the 10th certificate had for me. It was an age proof. Before Aadhaar card and all you came into the picture, now even for that it is not required. So it's really of no consequence. Your entrance exam is going to be the major thing of consequence. So I think you should put every day possible from here onwards into your entrance exam process. Okay. So with that, I will just start today's session. If you or your parents have any other queries also, I'm always available. You can contact me personally by message or by phone. Okay, so don't worry about that. But yeah, if possible, do attend tomorrow evening's session. I will send you the exact timing and link and all later in the evening, so you can attend it. Okay. Right. So let's move on with our physics session today. Okay. Let's get to understanding some interesting things. Okay. So we were talking about motion along a straight line last time. What is also called one-dimensional motion. If at any time you want to discuss anything during the lecture, you have any question or doubt, please just unmute yourself and ask me the question. You can send a text message also, whatever is convenient for you. Okay. So this is also called motion in one dimension, or in short form, we call it 1D motion. So the very short form of it is 1D motion. So in this, we had seen last time that if we are describing the motion along the x-axis, then we define position by the x coordinate. So whatever is the x coordinate, that tells us what is the instantaneous position. That means at a given time, what is the position. Then we define displacement as simply the change in x coordinate, delta x. So final minus initial, though distance is different. Okay, distance may not be equal to displacement. So distance in general is greater than equal to magnitude of displacement, but it is the actual path length. So that is where things sometimes get a little complicated, and we'll discuss more examples today. The difference between distance, okay, the difference between distance and displacement, we'll discuss more about that today. Then we saw velocity, okay, and we saw that there are two types of velocities: average velocity, which is displacement upon time. So we can write that as delta x by delta t. So it is like a net displacement divided by total time. Whereas we also saw that there is instantaneous velocity. So this was the thing which was a little more complicated. Okay. And this is where we were understanding with the interpretation that instantaneous velocity is basically dx by dt, where this is a new symbol for us. Okay, so dx by dt is the value of delta x by delta t only, but under a special condition, and that condition is called a limit that delta t is extremely small. Okay, so practically speaking, if our total journey is of, let's say, a few minutes, but we record the displacement during 1 millisecond or 1 microsecond in between at some point of time, then that 1 millisecond or 1 microsecond can be treated as an extremely small interval of time compared to the total time of the journey of minutes or hours or whatever. So we can define the displacement in that 1 microsecond divided by 1 microsecond, or 1 millisecond divided by the value of 1 millisecond. We can treat that as the instantaneous velocity. So that is the difference between average velocity. Average velocity is total displacement divided by the total time of the journey, or the interval of time. So average velocity is defined for an interval, of time, which is delta t, let's say, which is some value of final time minus some value of initial time. Okay. Whereas instantaneous velocity, on the other hand, it is not defined for an interval of time. It is defined for an instant. It is defined for an instant of time. So that instant is from some time t to a new value of time, which is t plus dt. So that dt is that very small interval of time. So that tells us the difference between instantaneous and average. So this is that extremely small interval of time, very small time. So practically, if we are using a speedometer or something like that, then that time is so short that during that time the wheels of the car have made a single rotation or two rotations. So in the context of the whole journey, the whole journey of the car or vehicle, the wheels would have made literally thousands or millions of rotations. So out of that, if the speedometer has recorded the time taken for one rotation of the wheel, so that one rotation is a very short interval of time, so it can be treated as dt instead of delta t. So in that single rotation, the displacement, which is 2 pi r divided by the time taken for the single rotation, that will be treated like an instantaneous velocity. Okay. Whereas if we have some other mechanism of measuring time, which is for even shorter period of time, then such a speedometer will be even more accurate. So in terms of measurement of quantities, मैं dt को जितना छोटा कर सकता हूँ, the smaller the value of dt possible, you can say the more accurate is my measurement of instantaneous velocity. Okay. So that is about instantaneous velocity. Now, the next thing, what we had understood, the difference between instantaneous and average velocity in terms of the graphical representation. So if we are representing the coordinate, the x coordinate or the position versus time graph. So if we have an x, let's say in meters, versus a t, which is, let's say, in seconds for a given body which is moving, and we see that the x coordinate is changing like this with respect to time. It increases, decreases, then again increases, then something like this. So that means what is happening is that our body is first moving from some position x1, let's say this one, x1 over here, to some value, let's say x2 over here, which is further down. So it is going from x1 to x2 initially like this. Is going in this direction from time t equal to 0 to t equal to t2, let's say. Okay, where this is the time. But then what is happening from t2 onwards to t3, its x coordinate is actually decreasing, because you can see x3 has a value of less than this. So in the next interval of time from t2 to t3, you can see SR. It is coming back to some position over here, let's say x3. Okay, and then from t3 onwards, again its position is increasing. So let's say at time t4, it is reaching some other x coordinate, which is, let's say, x4. So that is even ahead of x2. So now next part of the journey, it is going from here back like this to some position over here, x4, and like that. So the fact that in this graph, you can see that the x coordinate, which is on the vertical side, not on the horizontal side. So x coordinate kya ho raha hai? It is increasing, decreasing, then again increasing. So that means if you visualize the motion on the x-axis, वो कैसा motion हो रहा है? It's actually going forward, then coming back, then again going forward. Okay, so that is the interpretation of this. Okay. Now in this graph, now if I take some time, let's say TA, okay, some value of time, it might be 1 second or something, for example, and some other time, let's say TB, which might be, let's say whatever, 60 seconds or something like that. Okay. And I ask you, what is the average velocity from TA to TB? That means I'm taking my interval of time, delta T, to be TB, which is the final time, minus TA, which is the initial time. So on the graph, we will see, of course, in terms of definition, we will see that the average velocity, by definition, वो क्या हो गया? वो delta x by delta t हो गया. So it should be treated as the value of x at b minus the value of x at a divided by the value of t at b minus a. So we will have to plot this point over here to understand that, okay, this is my value of xa. And then we'll have to plot this point on the graph to understand that, okay, the value of x here is this. So now we notice that on this graph, if we join these 2 points, that is the point A and the point B, ये दोनों को, if we join them by a straight line, then that straight line has the very interesting property that its slope is equal to delta x by delta t. So this straight line only has the property that this thing is delta x, that is xb minus xa, and this base over here, this only is delta t, that is tb minus ta. This angle is theta. So you can see that the average velocity is nothing but tan theta. So it is basically what we say is the slope of something called the secant line. It is the slope of the secant line. This sort of a line is called a secant line. The line joining 2 points on a graph, it is called a secant line. So this is what we call the geometrical interpretation of average velocity. Geometrical or graphical interpretation of average velocity, that it is the slope of the secant line of the position versus time graph. Okay. If we look at a position versus time graph, then the slope of the secant line, that represents the average velocity. Okay. Now, likewise, we also saw. Okay, so I'm going a little bit fast in this section because we have discussed about this earlier. Okay, but the next thing we are going to discuss will be application of this. So I want to do a quick review of this. So I'm going fast through this, but if you have any question in between, please don't hesitate to ask. Okay, we are not in any hurry whatsoever. Okay, so you need not worry about time taken and all that. Okay, so now in this same graph or whatever, we're looking at x versus t. Now instead of this thing, the value of average velocity, now I want to calculate instantaneous velocity. Okay, that is instantaneous velocity. Okay, at some time, let's say t equal to t naught. So remember, it is defined for an instant. It is not defined for an interval. So suppose that time t naught is this one. This is that time t naught. So now the thing becomes a little bit more tricky. What I have to do now is that I have to figure out that, okay, at time t naught, my position was this value, let's say. And then literally what I'll have to do is, if I'm, doing this problem using the graph, like I have only the graph as the information given to me. So I'll measure this value. Okay, so this value is x naught. Now what I'll have to do is I'll have to magnify the graph a lot. So I'll try to magnify it as much as I can over here without it pixelating or something. So suppose मैं जितना हो सके मैंने graph को magnify कर दिया. Now I saw that in my graph, the particular time t naught I was seeing, that was this point over here, the point that I've just dotted. Now what I'll have to do is I'll have to take the next consecutive point on the graph. Now, literally जो ये वाले point के बाद जो next वाला point है, next consecutive point, for that point I'll have to calculate that what is the value of time and what is the value of x. Okay, so whatever the value of time I will get, like it might be 1 microsecond later, it might be 1 millisecond later, that is depending on how clear my graph is. Okay, so this value of time here, this is becoming t naught plus dt, because it's a very small interval of time. And correspondingly, when I draw this horizontal line over here, this one, so this value of x that I'm getting here, this will become x naught plus dx. So this value here, it is becoming x naught plus dx. Okay, so now even more tricky. I have to join these 2 points with, a sort of a straight line, which might be something like this. Let's say it's a little difficult to draw, but so let's say 2 consecutive points on the graph, I'm joining them with a straight line. So this type of a straight line, what it is called the tangent line. So this sort of a graph, it is called a tangent line, this straight line. So this is called a tangent line. And you can see that, if I magnified the tangent line a lot now, so my point, one of the points was this. Now, this was the point which had x naught comma time t naught. And the next consecutive point I took was this one. So I magnified that a lot, let's say. So it's become like this, x naught plus dx, t naught plus dt. Ye iske coordinates ho gaye. So these 2 points only I've joined with the straight line, these 2 consecutive points. So yahi straight line ka jo slope hoga, that slope only, that tan theta will only be this value, which is dx divided by this value, which is dt. So v will again become tan theta, but this time that tan theta is dx by dt. Okay, and so it is nothing but slope of tangent. So that is the difference between the instantaneous velocity and average velocity in terms of graphical representation. That instantaneous velocity, it is the slope of the tangent line of x versus t graph, whereas average velocity was the slope of the secant line. Okay, so as you can see, the whole business of tangent line is a little bit more complicated compared to secant line. Tangent line is a lot more complicated. So secant line is just, you have taken 2 points which are far away from each other, so it's very easy to draw that straight line. But tangent line mein hum kya kar rahe hain? We are giving you the value of only one time t naught. Now you have to plot that point, and you have to also plot the next consecutive point, which is quite a bit more challenging. So we have to plot that next point, and we have to then join those 2 consecutive points with a straight line, and that is called the tangent line. So we will develop some techniques of calculating this thing. We will develop some techniques, and that technique is basically what is part of calculus. The early part of calculus, differential calculus, was developed by Newton and Leibniz precisely for solving this issue only, that the instantaneous velocity, how it can be defined in terms of the position versus time relationship. That was the problem they were trying to solve mathematically in physics, and that is what gave birth to the whole mathematics of calculus and differential calculus in particular. Okay, so we will talk about this a little bit more coming up. Okay, so now let's take an example to understand more about this. So we'll take an example now where it is given to us that a particle moves along the x-axis such that its position x, which is given in meters, varies with time t, which is given in seconds as. So the relation of x versus t is given to us like this, that x is equal to 10 plus 2t plus t square. So this is what is given to us over here. Okay. So first of all, what we have to do is find the displacement in meters, okay, from t equal to 0 to t equal to 2 seconds, and secondly from t equal to 2 to t equal to 4 seconds, and thirdly from t equal to 0 to t equal to 4 seconds. Okay. Also compare the distance traveled for each of these parts, A, B, and C. That's the first thing you want to do. Okay. Then the second thing is, okay, plot an approximate graph of x versus t and find average velocity for the same three intervals, same as above. Okay, so that is 0 to 2, 2 to 4, and 0 to 4. Okay, and third part, which is going to be more tricky for us now, which through which we will start learning more about instantaneous rate of change. We will calculate the instantaneous velocity at, let's say, t equal to 0 second. When the motion just starts, what is the initial velocity it is starting with? And then again at t equal to 2 seconds. Okay. Okay, so I think you can just get started with the question, get a feel of it. Okay. Now, before you absolutely start with the graph and all that, understand one thing over here, that here in the equation x is equal to 10 plus 2t plus t square. Okay, there are some physical constants involved. This term 10 is actually 10 meters, and it is a constant because x is in meters. Okay, but similarly in this term, okay, the quantity 2 is what, 2 meters per second. Okay, and it is a constant. Okay. And similarly in the third term, this one in t square, you can see that this t square is actually 1 into t square, where that 1 is equal to 1 meter per second square, and that is also a constant. So there are three hidden constants in these equations, and those constants are what we call physical constants. They are not numerical constants because they have a unit. Okay, so you have physical constants, 10 meters, 2 meters per second, and 1 meter per second square in the particular equation. These are the physical constants in the given equation. We will learn more about such physical constants versus numerical constants in a future chapter called units, dimensions, and measurements. Okay, so, but here you can understand because x is in meters, x is given to us, this is in meters. Therefore, each of the terms on the right hand side also has to be in meters. So the 10 is independent, so it has to be in meters. But the 2t also has to be in meters, whereas t is in seconds. That means the 2 must be in meters per second. Is this point clear to all of you people?
Yes, sir.
Okay, very good. Okay. Okay, so just start with this question then. Now you will find it's pretty easy to calculate the first and second part. The third part is where we will need to discuss a little bit. But if you have any ideas of how you want to do the calculation, okay, we'll discuss about that also. Okay, people. So if you have got the answers of the first part and second part, you can just send it to me on the chat message or okay. Okay, very good, Abhinav. Just check the C part once. Okay, might have made a typing mistake, but otherwise is correct. Yeah, Abhinav, you check the C part once of your answer. Okay. Okay, wait, I will unmute you. Just a second. Yeah, check now again.
Yes, sir.
Yeah, have you checked the C part, Abhinav?
Yes, sir. It is coming 34 only.
Okay, then just check A and B again because see the sum of A and B should be C, no?
Yes, sir.
You understand? Yeah, तो कुछ कहीं there's some small numerical mistake. Just check it once. Okay.
Yes.
Anybody else got the answer? Please let me know. Okay, so I'm just giving you a brief idea of the solution. So x is equal to 10 plus 2t plus t square. So now if we are defining displacement for any time interval from let's say time t1 to t2, the displacement will be just x2 minus x1. That is my delta x. Okay, where x2 is equal to the value of x at t equal to t2 and x1 is the value of x at that time t equal to t1. Okay, so this is the method that we have to use, and in this method we will calculate x1 and x2 using this formula now. So for the a part, I'm taking 0 to 2 seconds. That means I should take t1 as 0. So I should take x1 as how much? 10. It will be in meters and it will be plus, because just put the value of t as 0. So you can see that x at t equal to 0 will be 10 plus 2 into 0 plus 0 square. So that's how it's coming out to be plus 10. Okay. But similarly, t2 I'll have to take as 2 seconds. So x2 will become how much? So x2 will become 10 plus 2 into 2 plus 2 square. So that is 10 plus 4 plus 4. So that will become plus 18 meters. Okay. So now I can see that the first part's answer will become plus 8 meters. The direction is positive. Okay. So therefore, S, the displacement from 0 to 2 seconds, that should be equal to plus 8 meters. So this should become my answer. Now, similarly, for the second part, I'm taking from 2 to 4 seconds. So I should take my t1 as 2 seconds. So I've already calculated that x1 will be how much? X1 will be 18 meters plus 18. But similarly, t2 I should now take as 4 seconds. So x2 kitna hoga? So for that we need to again calculate. x2 will be 10 plus 2 into 4 this time plus 4 square. So 10 plus 8 plus 16. So that is becoming how much? 18 plus 16. So that is 34. Okay. So this is plus 34. Okay. So now I can see that the displacement in this next interval is this x2 minus x1. So 34 minus 18, that will give us how much? 14 plus 2, 16. So plus 16 meters. Yes, very good, Nitish. Okay. So very good. Now, Abhinav, you understood now how the last part is coming?
Yes, sir.
Very good. Okay. So the last part, we have two options now. For the C part, we can either calculate 0 to 4 seconds, where we can see that T1 को 0 लेंगे, so x1 मेरा कितना हो गया? It is plus 10. T2 को we will take as 4 seconds. So my x2, which I have calculated here, this one is 34. So one option is like this. So my displacement from 0 to 4 is going to be 34 minus 10. So that is 24 meters. So that's one way. Or the other way is, we don't need to do all this calculation, because we also have the option that the displacement from 0 to 4 is nothing but the sum of the displacement from 0 to 2 plus 2 to 4. So why to do all this calculation? I already know that 0 to 2 it is plus 8 and this is plus 16. So I can also check that, okay, that means it is plus 24. So you can see that this agrees with this. Okay. So, in physics, very often it happens that we have more than one method of calculating or checking one calculation that we've done. And you should always be mindful of that, because, that way you can keep mentally checking what you've done by one method. It's agreeing with the second method. So then you have not made any mistake while calculating. Okay. Okay, now let's talk a little bit about distance. And for that, we need to understand the graph a little bit. Okay. So this is where we are going into something which is probably going to be a little bit advanced for us, but we will learn it slowly. So to understand distance, we need to understand these two things here, that in 1D motion, that is one dimensional motion, okay, distance may be equal to displacement, a mod of displacement, or distance on the other hand may be greater than mod of displacement. Less than कभी नहीं हो सकता है, that we all understand. It can either be greater than or it can be equal to, but it cannot be less than. Okay, so let's understand in which case it is greater than and in which case it is equal to. This happens when the direction is not changing. It's rather, you can say, it is never reversing. So it's just continuing in the same positive direction or the same negative direction, whatever be the case, during the motion. Because in 1D motion, it cannot change its direction by 60 degrees or 90 degrees or anything arbitrary. It can only change its direction by 180 degrees, because it has to be along the straight line. Okay. But this will happen when direction reverses, okay, at least once. It can reverse multiple times also. It can go back and forth like an oscillation, but at least once if it reverses direction, then my distance will become greater than the displacement. So now let's come back to the given equation, and from that let's understand whether this is happening or not. Okay. So now, given that my x was 10 plus 2t plus t square, you can notice here that the quantity 10 is a constant. So that is not changing with time. Okay. Then the second quantity 2t, what kind of quantity it is? It increases with time. It never decreases. So it's a uniformly increasing quantity. It's uniformly increasing with time. Because if you think of just the quantity 2t, t versus let's say some quantity y is equal to 2t, that's a line like this. So it's always increasing, you can see. Okay. Now let's come to the third quantity, t square. What we can say about that? T square is also always increasing. It's never decreasing. Always increasing with time. So if you separately plot a graph of z, let's say equal to t square versus time, that graph will be like this. It will be a parabolic shaped thing. At t equal to 1, it will be equal to 1. At t equal to 2, it would have increased to 4. At t equal to 3, it would have increased more sharply to 9, like that. So this point here, wherever it is, it will be 3,9, like that. Okay, so this kind of a graph is called a parabolic graph or a quadratic graph. So we'll come to this in more detail later. So you can see that all the three terms individually, none of them are decreasing. That means your x is never decreasing with time. Okay, so one term is constant, one term is increasing with time, and the third term is also increasing with time. So the sum of the three terms will always increase with time. If I say that x is equal to a plus b plus c, and none of these are decreasing, because this one is constant, this one is increasing, this one is increasing, this one is increasing, this one is increasing, this one is constant. So what that says, that means x is also increasing with time. Okay, so this tells me that x, that is the position, is always increasing. So what that tells me, that tells me that the direction never reverses. It shows me that the direction of motion is always along the positive x direction. Always positive. So that tells me what? That I'm in that first category, that distance is equal to magnitude of displacement. So distance traveled from 0 to 2 seconds will be equal to magnitude of displacement from 0 to 2. So that will be whatever it was. I think 10 meters was the answer. Then similarly, distance traveled from 2 to 4 will be equal to magnitude of the displacement from 2 to 4. Here we don't even need the magnitude because all the displacements were positive. But anyhow, so that was 14 meters, was it? Sorry, 8 and 16, my mistake. And accordingly, the distance traveled from 0 to 4, that is also how much? That is equal to the magnitude of displacement from 0 to 4. So that is 24 meters. So this is the comparison of the distances with respect to displacements. Okay. So I'll just minimize this a little, just understand this part once more if you like. This will also help us in the third part where we are trying to plot an approximate graph. And from the graph, we are going to talk about average velocity and later instantaneous velocity. Okay, so let's start from this part where we are understanding the relationship between distance and displacement. This was Okay, so I'm just scrolling down to the next part where we have come to this final conclusion. Now, in this part, I want you to very carefully understand this thing that I've explained, that I've expressed the displacement, or rather the position, as the sum of these three quantities, 10, 2t, and t square. So let's say these three quantities are A, B, and C. So out of that, A is a constant, but B and C are both increasing with time, as you can see in these two graphs. This one was the B part and this one was the C part. So they're increasing with time. So if I say that one quantity is the sum of three other things, where one is constant and the other two are increasing, then definitely the quantity on the left hand side, which is X, will be increasing with time. So this is a very important part of our judgment. So we understand that this comes in that category where distance is equal to the mod of displacement, because the direction of motion is never reversing. It's always in the positive direction. Okay, very good. Achha, anybody has thought any other approach to this particular situation here? Why distance and displacement have same value? Anybody has thought any other idea? You can tell me.
So the average velocity is increasing.
Okay, how very good. How did you come to that conclusion? Average velocity is increasing.
Sir, means you asked us to calculate the average velocity from 0 to 2, 2 to 4.
अच्छा मतलब वही वाले values देख के ना. Okay, so
Yes.
at least for those intervals I can say it is increasing, है ना. But उसमें
Yes.
can we be 100% sure of enough? You know, because I'm, for example, I don't know the average velocity from 0 to 1, then 1 to 2, then 2 to 3. ऐसा नहीं पता ना मेरे को. You're understanding my point now, Abhinav?
Yes, yes, yes.
Okay. Okay. Achha, now I'll give you a little bit of hint. Can you relate this problem to something that you are very familiar with, like the three equations of motion? ना जो आपने 9th में पढ़ा होगा ना. B is equal to U plus AT, S equal to UT plus half AT square. Can we connect this with that? Think once. यहाँ पे देखो क्या हो रहा है. X is what sort of function of time? It is quadratic function of time, ना? So that means
Yes.
what kind of function of time is displacement? Yes. अगर मैं डिस्प्लेसमेंट देखूंगा ना, वो भी कैसा फंक्शन होगा? क्वाड्रेटिक फंक्शन ऑफ टाइम होगा.
Yes, sir. Yes.
Is that correct, people? Yes. So if displacement is quadratic function of time, that means what kind of acceleration we have? We have uniform acceleration, because S is equal to UT plus half AT square. So
Oh,
can
yes,
we
the three equations of motion are valid in uniform
correct,
acceleration.
correct. So we can connect it with that also, no? Okay. So that's the other thing we can do. We can also understand. So I'll just write that point down over here, okay, and see if it makes sense to all of you. Let me know. Okay. So here I can see that if you observe, X कैसा function है? It's a quadratic function. Okay. So if position is a quadratic function, that means my displacement is also a quadratic function. It is a quadratic function or quadratic relation of time, like A plus BT plus CT square. So that's a quadratic function of time. So that means displacement, okay, as a function of time, that will also be quadratic. So that means that S will be of the type UT plus half AT square. Okay, so that happens only for uniform acceleration. Okay, so let's understand it that way now. How we can relate it with uniform acceleration. Okay, so see now from this given equation, we'll interpret two things. That x at t equal to 0, kitna hai? 10 meters hai. So this is the starting position, and x at some general time t is 10 plus 2t plus t square in meters. So that means what is the displacement, okay, from 0 to t? That means displacement as a function of time. It is x at t minus x at 0. So the displacement as a function of time is 10 plus 2t plus t square minus 10. So this is what we call the instantaneous displacement, or the displacement from time 0 to t. Now this is displacement as a function of time. Okay, that means from 0 to t. Now this brings us to the point we were talking about earlier, that what kind of function this is. This is a quadratic function. It is a quadratic function of the type s is equal to ut plus half at square. So if we compare these two equations now, what it is showing us, it's showing us the numerical value of u and a. It shows us that u is equal to plus 2 meters per second, and the acceleration is equal to plus half, or sorry, plus 2. Half a is equal to 1, so it is plus 2 meters per second square. So most importantly, it shows us that initial velocity u, okay, and the uniform acceleration a are both positive. So that also gives us the same information. So that immediately implies that the particle or body, whatever, is always moving along the positive x-axis. Okay. Now see, this comparison will not only help us understand this thing, that distance is equal to magnitude of displacement, but it will also help us for the second part of the question, where we want to calculate average velocity. And we want to calculate the last part, instantaneous velocity. This will also help us for that. Okay. So this will first of all tell us that distance is equal to magnitude of displacement. That's one thing. Then it will also tell us that we can use this relation v is equal to u plus at for instantaneous velocity. It will also tell us that we can use the formula for average velocity as u plus v by 2. Or that is the same thing as displacement upon time. Okay, so we'll see how we can make use of all these things. But this is just another interesting way of dealing with the problem, that we just observe that okay, x is a quadratic function of time. So the moment we know that okay, x is a quadratic function of time, we can connect it with some knowledge that we have from before, that if displacement is of the type ut plus half at square, that means compulsorily it is uniformly accelerated motion. It cannot have a variable acceleration, or its acceleration cannot be zero also for that matter. Its acceleration has to be a non-zero constant. That's the only way my s can be of this type, that it is ut plus half at square. So we can also connect the question this way. Okay, so make a brief note of this point if you like, and then come to the last part, where you will calculate the instantaneous velocities also. Obviously second part also average velocity, but that you know how to do. Just divide the displacement by the time interval, you will get the average velocities. Okay, but more importantly, instantaneous velocity, you can use this method also. We don't need to actually make the tangent, draw its slope and all that. Okay, we can do it this way. So just give this a shot, then we'll discuss more about this in a minute or two. Okay, so now we will come to the average velocity part, but before that, we have we have to draw the approximate kind of graph. Okay, so to draw the graph for the second and third part, for x versus t graph, let's make a set of values. Okay, so x is 10 plus 2t plus t square. So t equal to 1, we can see x, sorry, t equal to 0 we started with. So we can see that x's value was 10. Then t equal to 1, for example, you can see x's value will become how much? 13. Then t equal to 2, we had seen x's value was how much? It was 18. Then t equal to 3, let's calculate. See, x's value is 6 plus 9, that is 15, so 25. Okay, then t equal to 4, we had seen x's value uh, was how much? 8 plus 16, that is 20, it was 34. Okay, then let's also calculate t equal to 5 seconds just to get one more value. Okay, so 5 or 6 values should be enough to understand the trend of the graph. So you can see it is 10 plus 10 plus 25, so it is 45. Okay, and then let's just calculate some values like this. You can see it will become 10 plus 20 plus 100, so it's increasing to 130. Okay, then for example at t equal to, let's say, 100 seconds, become a very large value. It will become of the order of magnitude of 10 raised power 4. So that will give us some kind of an indication what kind of graph to plot here. So we can see that we have very rapidly rising graph. So it started from the value of 10, let's say that's over here. Okay, then it went to, at 1 second its value increased to 13. Then at 2 seconds its value increased to 18. So that's somewhat larger here. Then at 3 seconds its value increased by even more. So it's, let's say, gone somewhere here. Its value is 25. I'm not drawing it exactly to scale, but you can see that. So it would have increased to 34. Then 5 seconds, it's increased to 45. So let's say that's somewhere here. Okay. And like that, it's very rapidly increasing. So the graph is something like this, very rapidly increasing. Okay. So our x versus t graph, if we draw a very approximate kind of graph, we can see that it has a shape like this. It curves in this manner. Curves like this. If you compare it with a straight line, it keeps curving like this. Okay. So for example, if I have to use this graph only to calculate the average velocity, then I have to draw the tangent lines, sorry, the secant lines, okay, between the quantities which are given. So we can do that. So I'll make a copy of this graph and do that also. All right, so now let's see that strictly if I want to go by the graph method, how I will calculate average velocity. Though, like I said, it's not really necessary because we can just divide the displacement by the time taken. But if I want to do it the proper method graphically, so for the first part between 0 and between 0 and 2 seconds, I'll have to join these 2 points with this straight line. So this is my secant line. This is secant line for 0 to 2 seconds. Okay. So the slope of this one will be equal to average velocity from 0 to 2 seconds. So that you can see will be equal to 18 minus 10 divided by 2 minus 0. x2 minus x1 upon t2 minus t1. So you can see that will be 4 meters per second. That is the average velocity. Okay, from this to this. Okay. Now similarly, I'll just do one more part instead of doing all the parts. Okay. So if I calculate, let's say 0 to 4 seconds, then how that should look like. So 4 seconds is here, 34. Okay. So this is the straight line I'm talking about. So this second line that I'm drawing, this is the secant line between for 0 to 4 seconds. So this one's slope should be equal to the average velocity from 0 to 4 seconds. So that should be equal to delta x by delta t. So that will be 34 minus 10 divided by 4 minus 0. So that is 24 by 4 or plus 6 meters per second. So this is one way of calculating the average velocity. Okay. Alternately, I also have the relation from equations. S is equal to ut plus half at square, where u was 2 meters per second and a was 2 meters per second square. We also have v equal to u plus at. So that is equal to 2 plus 2t. So therefore we can see that u, which is v at t equal to 0, the initial velocity at t equal to 0 is plus 2 meters per second. Okay, the velocity at t equal to 2 seconds is 2 plus 4, that is plus 6 meters per second. And we can also see that the velocity at t equal to 4 seconds is 2 plus 8, that is plus 10 meters per second. So we also have this extra information. So now we can use the property of uniformly accelerated motion for uniform acceleration. You can also use the important property that average velocity is u plus v by 2. So therefore, for the first part, average velocity from 0 to 2 seconds should be equal to u plus velocity at 2 seconds divided by 2. So that you can see is 2 plus 6 divided by 2. So that is plus 4 meters per second. And that you can see is in complete agreement with the answer we've got here. Okay. And similarly, you can also see that we are calculating the average velocity from 0 to 4 seconds. You can see that that will be u plus v at 4 divided by 2. So that is 2 plus, you can see v at 4 was 10 divided by 2. So that will be plus 6 meters per second. And now you can see that is in agreement with this value that we've got. This 6 meters per second is in. So you can see there are so many different ways of solving the same problem and different ways of interpreting the same information. Okay. That's one of the things which is very satisfying in physics, that you have different ways of interpreting the same information and the same system, and they all converge to the same solution. Okay. So that also helps us in understanding in more detail. Okay, now let's come to the final part of the question where we are calculating the instantaneous velocity. Okay, now for the instantaneous velocity, now we will go in the reverse order. First, we will use the fact that it's a quadratic function, so we can always rely on our equations. Then we will come to the graph method. Okay, so first we will go with the method that since s is equal to ut plus half at square, implying that acceleration is uniform. In this case, that was 2t plus t square. So u was plus 2 meters per second and a was plus 2 meters per second square. Okay, so it implies that velocity is u plus at. So this is the formula for instantaneous velocity. So I can just use the formula based method. Okay, this is happening because the question gave us x as a quadratic function. If the question had given some different value of x, then we would not have been so lucky. No, but here that was quadratic, so we can imply this. Okay, so we are getting the formula that v is equal to 2 plus 2t. So that is showing us that our instantaneous velocity at t equal to 0, which is basically a u, is nothing but plus 2 meters per second. Our instantaneous velocity at t equal to 2 seconds is nothing but 2 plus 2, that is 4 meters per second. Our instantaneous velocity at t equal to 4 seconds, if you want to calculate that, is equal to 2 plus 8, that is plus 10. Okay, in the case of velocity, it is always important to give the direction also. So the plus minus sign should be indicated. Okay, so this is the easy method here. This is the formula based easy method. Okay, but remember that this we are able to apply, okay, only because s is a quadratic function of time. If this were not the case, then we would not have been able to apply this easy formula based method. Okay, so now in our physics, we have to graduate from this easy type of question to the more tricky type of question where s may not be a quadratic function of time. So in that case, what do we do? So that's what we'll explore through this question coming up. I mean, through this next method, which I will explain.
Sir,
Yes, beta.
sir, why have you taken the value of u as 2 meters per second for all values of time?
हाँ, because see, मेरे पास जो equation दिया था ना बेटा in the question, the equation that was given was that x is 10 plus 2t plus t square. So from this I got s is equal to 2t plus t square. No? Now this equation I have to compare with which one? I have to compare with s is equal to ut plus half at square. So that is only showing me na, that u is equal to 2, you know, and a is equal to 2, but in meters per second, and this is in meters per second square. Got it now?
Sir, but at different values of time, the
No,
initial
no, no.
velocity is different, no?
इसमें okay, इसमें what is the meaning of u? It is the initial velocity, ना?
Yes.
in this equation, what is by definition u is a constant, na? So u is what? It is the initial velocity. So it is nothing but the velocity's value at t equal to 0. U is nothing but v at t equal to 0. Got it, no?
Yes, sir. Yes.
So that is why we will use this.
Okay, sir.
And A is the uniform acceleration. So it is having a uniform acceleration of 2 meters per second square, or we should say plus 2 meters per second square, but it is having the initial velocity of plus 2 meters per second.
Okay.
Okay, so people, this method is clear now to all of you.
Yes, sir.
Okay, these three answers you understood now, how we got. Okay. Now we will come to the more advanced way of looking at this problem, okay, which is that we will calculate instantaneous velocity to calculate v as dx by dt, or slope of tangent. Okay, where we understand that dx by dt is equal to what we call delta x by delta t, but in a special condition, which from now on we will call a limit. Okay. Delta x tending to 0. So I'll explain what this means. This term over here, it means it is solved under the limit, which you can think of as a condition that delta t, sorry, not delta x, but delta t. So this is solved under the limit that delta t is, now this symbol means tending to 0, that delta t tends to 0. So what that further means is that delta t is very, very small. Its value is very small. Okay. So it means that the value of delta t is extremely small. Okay. So it tends to 0. But remember, it is not 0, not equal to 0. It tends to 0, but it is not equal to 0. But not equal to 0. Okay. So delta t tends to 0. It implies that delta t is not equal to 0. Okay. It is not equal to 0, but it's very small. Because remember that division by 0 in maths is an undefined operation. We cannot divide something by 0. So we cannot make delta t equal to 0. But what we are doing is we are making delta t extremely small. So in maths language, that is called limit delta t tending to 0. So now we have to put this in practice, that how we will calculate dx by dt by delta x by delta t with the limit that delta t is tending to 0. Okay, so let's understand this now. So say we are doing the first part, the A part, or I will do one of the parts here. Okay. So let's say we are doing the B part. So we want to calculate the instantaneous velocity at the moment t equal to 2 seconds. Okay. So according to this interpretation, what it means, instantaneous value is dx by dt at the moment t equal to 2 seconds. So further it means what? That it is the limit delta t tending to 0. Under that condition, we are calculating delta x by delta t at t equal to 2 seconds. Okay. So graphically, what that means is that earlier graph that we had drawn, yeah, this graph. Okay. So I'm going to try and super magnify this, see if we can make some sense out of it. Okay. And also I will try to smooth out this graph a little first. So let me say I'm trying to draw slightly more smooth shape. So this graph is something like this. Okay. So now in this graph, I want to calculate the slope of tangent, but at which point? At t equal to 2 seconds. Okay. So let's focus on first the moment t equal to 2 seconds. That's over here. And the value of x at t equal to 2 seconds was 18 meters. Okay. Now, next thing what we have to do is we have to plot a point very, very close to this. So that we can draw the tangent line. And the closer these two lines are, the more accurate my calculation is going to be. So at this second point of time, the time should be 2 plus dt. Okay. So this is my t2. Okay, whereas my t1 is this one. It's equal to 2. So accordingly, here you can see my x1 was equal to 18. Okay. But my second one, x2, will be equal to 18 plus some dx. And so when I join these 2 points with a straight line, next, this point and this point, when we join it with a straight line, that is my so-called tangent line. Okay. At t equal to 2 seconds. That is the tangent I've drawn. So slope of this tangent line now will become my slope of this tangent line will be dx by dt. So it will be the instantaneous values velocity. I mean, instantaneous velocity's value at t equal to 2 seconds, because I've drawn the tangent at that point, t equal to 2 seconds. Okay. So is the interpretation of the graph clear to all of you over here? I mean, we have not done any calculation yet, but what we are interpreting in terms of graph, so that point is clear.
Yes, sir.
Yes, sir.
Okay. Okay. Very good. So now what we have to do is we have to develop some kind of maths by which we can actually calculate this slope. So let's do that. Okay. So for that mathematics, okay, we will use this information only that. Okay. So we can see here that in this graph, at t equal to 2 seconds, the value of x1 which we have taken was 18 meters. Okay. Now at the value of t2, which is 2 plus dt. Okay. What is the value of x2 going to be? So let's calculate that from the above given equation. X2 is 10 plus 2t. So that t will be how much? 2 plus dt. Okay. Or let's first write it like this. It will be 10 plus 2t2 plus t2 square. Okay. Just like this x1 was 10 plus 2t1 plus t1 square. So it was 10 plus 2 into 2 plus 2 square. So that's how it had come out to be 18 meters. Okay. So now like this, we have to calculate this. So it is 10 plus 2 into 2 plus dt plus dt whole square. Okay. Now we will do one thing. We will do a bit of approximation. We will do an approximate calculation. So this is x2 and this is x1. Now let's test this with some values. With values of dt, which are very small. Okay. So just tell me what do you think is appropriately small value of dt? Just think any number that comes to mind. I want a small value of dt. तो कितना लेना चाहिए मुझे dt का value?
0.1.
Okay, 0.1. Let's go with 0.1. So for example, suppose we say dt is equal to 0.1 seconds. Okay, or we can say that is 100 milliseconds. So it's reasonably small, because you can see I'm seeing time in seconds. So 0.1 is not a bad value. It's quite small value. It's fine. So according to that, then x2 का value देखो कितना हो जाएगा? It will be 10 plus 2 into 2 plus 0.1 plus 0.1 squared. So how much it will become? 10 plus 4.2, correct, plus 0.01. So it will be 14.21 meters. This will be the value of x2. Is it correct? Just check once. Oh, wait a minute. I made some mistake here. This is not 0.1 square. It is 2 plus dt whole square. So it's little bit, life is little bit more complicated. Just a minute. So यहाँ पे कितना होना चाहिए? It should be 2 plus 0.1 square. So let me write an in-between step actually. So they should be 10 plus 2 into 2.1 plus 2.1 squared. Okay. Now somebody do this calculation for me and tell me how much this will be. Okay. 21 squares का कितना होना चाहिए?
441.
हाँ, so 4.41 आ जाएगा. Correct. Okay. So now this should be how much? It should be 18.61 meters. Is this correct? Just trying to minimize this one. Okay. So if I test with this value, I'm getting this value. So according to this, my instantaneous velocity should be dx by dt. So that dx will be 18.61 minus 18 divided by 0.1 seconds. This in meters divided by 0.1. So that is how much I'm getting. 0.61 divided by 0.1. So it should come out. It should come out to be 6.1 meters per second. Should come out to be this. This should be the instantaneous velocity. Now see, by the v is equal to u plus at method, how much we had got instantaneous velocity? We had got at t equal to 2 seconds. We had got it as 4. Was it? Okay. So this is not coming very accurate. Huh? Sorry, people, you have to make a correction here. The velocity at 2 seconds is not 4, it is 6. Okay. Please make a correction here. That's what I was thinking. It should come more accurate. V is equal to u plus 18. So at 2 seconds, you can see it is 2 plus 2 into 2. So that is 6 meters per second. So the okay. So please make that correction above also if you're noting now. So you see now it's coming reasonably accurate. It's not 100% accurate, but it's coming reasonably accurate. The instantaneous velocity according to formula was supposed to be how much? It was supposed to be exactly 6. But according to this estimation, it is coming to be 6.1. But that is when I'm using a speedometer that is measuring the instantaneous velocity taking dt, or the time interval is how much? 0.1 seconds. This point is clear now, people?
Yes, sir.
Okay. Now see, we will do one more round of this calculation and see even more accuracy. So now tell me a value of dt that is even smaller. Tell me an example of a value of dt which is even smaller. पहला value तो 0.1 लिया. Now somebody suggest something. Just think anything ना, that comes to mind. We'll use a calculator, so it's fine. So 0.1 से छोटा कोई value बताओ. Okay, let's take 0.001. Okay. Nidish, we'll go with your suggestion. So let's take a very small value now. So this will make it even more interesting. Okay, so we'll take the value to be, in our second example, we'll take dt to be equal to 0.001 seconds, not even 0.1. Okay, so let's see what we are getting with that. So x2 will be the value of x at t equal to 2.001 seconds. So that will be 10 plus 2t2, okay, plus t2 square. So according to this, our t2 should be 2 plus dt. So it should be 2.001 seconds. Okay, so that will be 10 plus 2 into 2.001 plus 2.001 squared. So let's do this calculation. So that's 10 plus 4.002 plus this will now become, save time, I'm just doing the calculation in a calculator, 2.001 squared. So that will become 4.004001. Okay. So that will make this total of 18.006001 meters. This will be the value of x2. So now according to this value of x2, our instantaneous value dx by dt is going to be equal to x2 minus x1 divided by dt. So remember, x1 was exactly 18. Divided by the time interval which we have this time taken as 0.001. So you can see this is becoming 0.6001 divided by 0.001. So it is becoming 6.001 meters per second. So you can see it is so much more accurate than our first value. Our first value was 6.1. So we had a discrepancy, you can say, of 0.1. First place of decimal was some approximation that we had done. Here it is in the third place of decimal. So even if we round it up to second place of decimal, we are getting the 100% accurate value. So this is showing us that the smaller the value of dt we take, the closer we will come to the actual value of 6 meters per second. Okay, people. So hope this is clear to all of you.
Yes, sir.
Very good. Okay. So now see, the thing is, you might think that, okay, every time we come to a problem like this, instantaneous rate of change or instantaneous velocity, we have to do a monster calculation like this. But that's not true, because now we will develop some formulae which are called the method of differential calculus to do this kind of calculation directly for us. Okay. So that is what we will look at next time. Okay. Next time we will start looking at applications of differential calculus. Which will give us a set of direct formulae for the calculation of this thing, the instantaneous rate of change. Instantaneous rate of change, or what is called the slope of tangent. Okay. So in the language of calculus, what will happen is that if we have, let's say, some arbitrary graph. So now I'm not necessarily talking about only displacement and time or position and time. I'm just saying that suppose we have some kind of function, y is a function of x, and we have some kind of graph representing that. Then at any point on that graph, at point x1, where the value of y is y1, we can calculate the slope of the tangent. Okay, so if this is the tangent, then the slope of tangent will become the dy by dx, okay, which is defined by the same limit that we are discussing today. Limit, this time delta x is in the denominator, tending to 0, delta y by delta x. But this limit will be calculated by a formula or calculated by a process called differentiation, or by a process called differential calculus, which is going to be a new branch of mathematics, or you can say applied mathematics and physics, which we will learn. Okay, so we will learn this method of differential calculus. So what will happen is that this function y equal to fx, it will be input into an operation called differentiation. So this is an operator called differentiation. Okay. And that operator will give us the output. Okay, so we'll input this function in this operator, and the output that we get from here will be dy by dx, okay, which is differentiation of the function fx. So for example, we will learn that if y is equal to x square, then the rate of change of y with respect to x, which will be given by differentiation of this function x square, will be given by a formula 2x. Okay. Now, obviously, this is just an example I'm giving you. So we will learn about this, how this is coming in the next lecture. This is coming from a rule in differentiation, and we will understand the justification of that rule also. Not just the formula, but we'll learn the justification of this rule. Okay. So some new and interesting things coming up in the next few lectures in physics. Okay. And we will concentrate on this part of calculus, but in such a way that every day while we are learning new things in calculus, we'll also be solving some physics problems using calculus. So it's not just going to be formulae and mathematics, but we will see the applications of those in actual practical physics problems. Okay. So people, hope today's lecture you have enjoyed and everything was clear to you. Okay.
Yes, sir.
Yes,
So
sir.
we'll very good people. Okay, so we'll conclude the session here today, and don't forget to attend the webinar session tomorrow if possible. If not possible for some reason, we will be recording it also and sending it to you. I will send you the exact time and the IDs later today. Okay, so wish you all the best and continue working, and most of all be safe, because this is a very dangerous and difficult time for all of us. Okay, so make sure you take all the precautions during this pandemic. Best of luck.
Thank you, sir.
Okay.
Thank you.